Welcome back. We are doing learning outcome number 2, classification, tabulation, and presentation of data. So basically our objectives, we want to classify the collected data. Remember we talked about collecting data before. We arrange tables, frequency distributions, and put it together into cumulative frequencies. Then from there we'll be able to draw pie charts and the bar graphs. So we should be able to do that after this lesson. So now, why do we need to organize and describe data? Remember I said statistics, we do it to make decisions. So we need to gain information from that data. Then we make informed decisions. So for us to do that, we should have tables, charts, and graphs. We cannot use raw data, the data that have been collected, to make decisions. So raw data cannot be used, it needs to be processed. Let's have an example here. We are organizing this qualitative data part into tables. Here we have employees identified by the employee number, whether it's a female or a male. So we have first employee is a male, second employee is a female, third employee is a male, fourth employee female, but we have 50 of them. So after classifying them by their gender as either male or female, we go now to see these people, they are from which department. First employee is a male, is from HR. Like that, second one is a female from marketing. The third one is a male from finance. So we have again another way of classifying. So from this data, how many males are in HR? So we go under male HR, it's just one. How many females are in marketing? It's F mark, it's only one. How many females are in marketing? How many males are in finance? So male finance 1, male finance 2, male finance 3. So there are 3. So we continue like that. Now we have processed our data into a table. Now we can make a decision, doing percentages from there. So basically, this is the data that we now have. Let's say we had 4 in HR who are males, so that we have males are how many? 4 plus 10 plus they are 19. Females, they are 10 plus 16, 26, 31. Remember we said we have 50 employees from our previous from where he started. Now we have this data, so we make the totals. So now we know that males are 19, females are 31, but we may want to know how many are in HR. There are 14. How many are in marketing? There are 26. How many are in finance? There are 10. But still total, there are 50. So this is what we call a frequency distribution table. A frequency distribution table. From this frequency distribution, we can use it to draw a pie chart. We may choose the way that we want it to be. So, like from the previous table, we had 4 and 10 HR, so they are 14. We had 10 and 16 in HR, so they are 26. So it's 14 over 50 times 360, we get the degrees. Then 26 over 50 times 360, because the circle has got 360 degrees. So it's 187, like that. But now we want to make it a percentage again. So we can say 14 over 50 times 100. So there are 28% HR people, 52% marketing, 20% finance. They make 100. But for the purpose of drawing our pie chart, we need the degrees. Then for the purpose of labeling, we need percentages. So these are, we may want to divide them into males and females. So we said the male are 19, female are 31. So 19 over 50 times 360 is 137. So this portion is for males. This bigger portion is for females. Still we follow the same process. For labeling, we use percentages. Then the data that we have, we can use it to make the bar graph. How many departments do we have? There are 3. HR, marketing, finance. HR, marketing, finance. So how many are in HR? There are 14. How many are in marketing? There are 26. How many in finance? There are 10. This is a bar graph because there is no link. If you are in HR, you are in HR. If you are in finance, you are in finance. We may also want to know how many female. There are 19. How many males? How many females? There are 31. Sorry, how many males? There are 19. So this is again here. So that's a bar graph. Then we may want to, for comparative purposes, of the males, we want to know the bigger number in them. We can see that of the males, the highest number is in marketing. Of the males, the highest number is in marketing. Then of the females, the highest number again is in marketing. So this we can use it for comparative purposes. Then still we may want to compare in HR. Males there are 4, females there are 10. In marketing, males there are 10, females there are 16, like that. Then we move to the next. We may do a categorized bar graph to see of the females, of the males. We want to know the component. This is a component whereby we want to know the bigger percentage, so it still gives the same information but in a different way. Then now remember, we are dealing with numbers separate. We can try to come up with a grouped data. Let's say we are given individual numbers, then we want to make groups. So this is how you do the number of classes. C is equals to 1 plus 3.3 log n. This log is in the calculator, so you punch. If you want, if you have 50, so it's C is equals to 1 plus 3.3 log 50. So let's see the ungrouped data. The ungrouped data that we have is this. We have collected this data. So we have 8, 5, 6, 11, 19, 11, like that. So how many do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 times 9, 45. So it's going to be 48 variables. 48 variables. So our width is going to be 7. But from our figures, the smallest number is 2, the biggest number is 22. So if we are going to have 7, so we need to find the width. So we say 22 minus 2. 22 minus 2. Then we get the width is 3. So we'll be adding 3 to get the. Then now we have to know now the values that should be included and that should be excluded. So their number of classes are 7. The class width is 3. Now we can move to the next. Now remember, we said our smallest number is 2, but the width is 3. So 2 plus 3, what do we get? 5. This become our upper limit. Then from that we say 5 plus 3, we get 8. From that we say 8 plus 3, like that. These become our classes. You may choose to write them in this format, or you may choose to use this format. Still, in some books you find it like that, but me, I prefer this format. Now our main goal is how many numbers are between 2 and 5. So let's go to our we have 2, 3, 3. So they are 1, 2, 3. These are the numbers which are between 2 and 5. So they are 3. The count is 3. We are grouping like that. This is a tally system. These are the numbers. So both they are the count. So this is now my frequency table. Between 2 and 5 there are 3. Between 5 and 8 there are 4. Like that, like that. So this is my... Now I may try to find percentages there. Like, remember when we add the numbers, we said there are 48. So since we grouped 48 numbers, our total still should come to 48. So this is the total. This is how you check whether you grouped all the items. If in our raw data there are 48, then here you find 45, it means you left 3. So this is how you find to see. So now I may want to find the percentage frequencies. So I'll be saying 3 over 48 times 100, 6.3%, 4 over 48 times 100. So it means they are 6.3% between 2 and 5. They are 8.3% between 5 and 8. They are 22.9% between 8 and 11. Like that, like that. You complete. Like that. You complete. So this is what we're doing. Now, I may want to find the cumulative frequency. This cumulative frequency, we use it to draw what we call an OGAF. I think at Form 5 or at O level you did this. It's there in the books. So the frequency is 3 and the percentage is this. So we are accumulating the frequency. So we start with 3 here. 3 plus 4, it gives 7. 7 plus 11, it gives 18. 18 plus 13, it gives 31. 31 plus 9, it gives 40. 40 plus 6, it gives 46. 46 plus 2, it gives 48. So that's the cumulative frequency. Then we may want to find the percentage of the frequency of the cumulative. It means now, like we did again, 3 over 48, 6.3. Then the second one, now our cumulative is 7. So it's 7 over 48. It's different from this one. This one we're taking only these numbers. Now we are taking the cumulative. So we may want to find this. So right, again we may find the midpoint. Remember we said our upper limit is 5, our lower limit is 2, our lower limit is 5, our upper limit is 8, like that, like that. So I may want to find the midpoint between this, each of this set. So it's 2 plus 5 divided by 2, 3.5. 5 plus 8 divided by 2, 6.5. 8 plus 11 divided by 2, 9.5. 11 plus 14 divided by 2, 12.5. 14 plus 17 divided by 2. So these are the midpoints. So we have done the midpoints here. So already now we have our midpoints here. And this is our summarized, this is our percentage frequency, this is our cumulative, this is our percentage, this is our midpoint. Now we want to draw. So we may draw now we put these values for the classes at the bottom. Always the frequencies, they go to the y-axis. Either the percentage frequency or frequencies, they go to the y-axis. If we are plotting, always frequency vertical, Then the class values horizontal always. Now we want to draw a histogram from our data. A histogram, it is just a bar, like between, this is the width of the bar 2 to 5, but its height is 3. The bar stretches from 5 to 8, but its height is 4. So the histogram, the bars are joined. It's different from the one which we talked about. The one which we did before, it was a bar. A bar is for unconnected information, so they don't connect. So this one is for connected. So the variables, like always, they go on the y-axis, the frequency y-axis. So this is what is happening here. This is 2 to 5, they are 3, 5 to 8, 4, like that, like that. So this is our histogram. It's just simple 2 to 5, that is this bar, 2 to 5, 3. Then still we may want to draw these midpoints against the frequencies. So midpoints, because they come from variables, they go to x-axis, frequencies vertical axis. When we do like that, we are plotting midpoints against frequencies. We come up with what we call a frequency polygon. A frequency polygon. This is a midpoint, and its frequency, midpoint is 3.5, frequency was 3, 6.5, frequency was 4, like that, like that, like that. Or you can just simply go to top of each bar here, you join, then you make straight lines between two. Then these are frequency polygon. Then we may want to plot the upper class limit with the cumulative frequency. So we take the 5, 8, what, then we take the cumulative frequency on the vertical axis. This is the graph that we come up with. It's 5 against 3, 8. 8 is the upper limit against what? 7. So it's 8 against 7, like that. 11 against 18, like that. So you plot, it should always come like a snake going upwards. Then you know that you have drawn it very well. Then we may want to estimate from this. Remember, our total is 48. Let's say we want to estimate the 50%. Where does the 50% fall? So you say from the cumulative that we have, right? Then you divide by 2, then you reach the 50. You drop it here. Then from, let's say we have this, then we want to find the 80th percent. So we say 80% here,